Hello, I'm Dr. Taylor, and this is Dr. Taylor's Pedagogical Notes, and today we're going to look at whole number subtraction. Okay, when we do our whole number subtraction, we are going to start from the concrete stage, and we're going to work up to abstract, and we're going to build our understanding as we go. So whatever level you're at, this sequence or this pedagogy should lead you to an understanding that will allow you to do abstract mathematics. And if it doesn't happen in one sitting, don't be, right? It's okay. It may not, but use this and review the slideshow after the video and build your skills up. You can give yourself the time it takes. There's no shame in that. All right, let's get started. All right, we're going to start with concrete, and here we have 3 and 5 again. Now, I know we're subtraction, but right now, we're doing subtraction, I should say, but right now, we still have 3, and 3 is still a sum of units, and 5 is still a sum of units. So don't be afraid that even though it says subtraction, you see plus signs, don't be confused. How do I make a 3? Well, I go 1 and 1 and 1 makes 3. And the word and in this case, not every case, keywords aren't always keywords. Keywords in context is what you have to understand. In this case, 1 and 1 and 1 is 3. 1 and 1 and 1 and 1 and 1 is 5. So let's use the colored squares for 3 and 5, just like we did before. And now we can label the squares individually. So you see it represents basically that in a manipulative form. I can group those together in any way I want, right? So I can group them in a way where I can see groups of 2s. I can group them in a way where I can compare them. And what I'm looking for with subtraction is how many more? How many more is 5 than 3? That's what it means. How many more is 5 than 3? Think about that. Could you do that by counting up and quickly decide that? I bet you could. Let's look at the strategy some more. There's 2, right? And since these are opposites, 1 minus 1, right? So what we have here is if we do 5 minus 3, we've got 5 minus 3. That means it's blue minus red. What's 1 minus 1? It's 0. So what does that mean? What do I do with those manipulatives when it adds up to nothing? How do I show nothing? Do I need an object to represent nothing? No, I really don't, do I? So nothing is represented by the absence of something, so I would take those off the table. All right? There's nothing there. And look, there's another 1 minus 1. It also adds up to what? That's right, 0. So that means to show nothing on the table, I would take those off the table as well, right? And yet another pair of 1 minus 1. Yes? Okay? So that's 5 minus 3. There's 5 minus 1, 5 minus 2, 5 minus 3. There's 2 more, but they're not one minus the other, are they? These are leftover ones. What's 1 plus 1 going to be? Right? Obviously, it's going to be the 2 more that's left over. So how many more is 5 than 3? It is 2 more. And your answer is 2. So understanding what subtraction is, it's really comparing 2 things and figuring out which one is more and by how much. That's what subtraction is. We think of it as the inverse operation of addition, and it is, because subtraction undoes addition, and we can talk more about that as we get more advanced. But the point is, how many more is this number of oranges than that number of oranges? If I have 5 and you have 3, how many more oranges do I have? Well, I have 2 more than you do, right? That's all we're asking with subtraction. So let's look at it graphically. Now graphically I could do with the strip diagram, again the same way, so I'm going to quickly go through, and there's no reason to belabor this, to make this video longer than it needs to be. Okay? And again, you can watch it again and again, you can pause, you can look at the slideshow, you can do a lot of things. Can I group again? Can I group pairs? Can I say 1 minus 1? Can I do that? Right? Is this not the 5 and the 3? And doesn't it say 5 minus 3? So 5 minus 3 means this minus that. I guess if I had put them this way, it might have looked a little more natural to you, but that's just an algorithm thing. It doesn't matter, right? When I'm looking at objects contextualized, I can just analyze the objects however they appear, and I can move them in whatever way that makes it easy for me to understand. Okay? So I'm going to put them right together, and in this case, I can compare what is touching what. Okay? Blue is touching red. That means they are going to cancel each other out, because what is 1 minus 1? It is, that's right, it is nothing. It is 0. It's gone. I can wipe it off the table, and I can say, well, look, I can wipe that off the table, and look, I can wipe that off the table. Could I have said, oh look, those three line up, and just wiped all three off the table right away without doing one group, two groups, three groups? Of course I could. But I want you to understand why you can wipe them off the table. Not just because they line up, because of what they represent. They represent a 1 minus 1. So if I wipe them all off the table, how many ones would that be? That would be 3. And how many of these would 3? So what would 3 minus 3 be? Yes, it would be 0. So as long as you're intellectually considering what you're doing and not just doing it because it's what you did last time, but thinking and understanding, right? That's what learning's about. No one can teach you to understand. Only you can explore and understand. I can't tell you knowledge. You learn through experience. I can only tell you, hey, here's a good way that you might be able to get some experience. But beyond that, you've got to get it yourself. All right, 2 more. Again, 5 is 2 more than 3. That's how many more 5 is than 3. Symbolic. Okay? So again, I'm going to use the number line. I'm going to start at 0 again because 0 is a good place to start when we're combining or looking at how many more. Unless those numbers are really, really big, right? If my number is, how many more is 230 from 235, I don't want to start at 0. That's crazy. I'd start close to those numbers or on one of them. But for now, 0 is a good choice. So I'm going to jump 3. Oh, I'm going to jump 5. Why? Because it's 5 minus 3, right? So 5 is going to the right on the number line because as I go that way, my number gets bigger, right? But what would be going the other way? It would get smaller. Now, maybe you don't have the understanding of what's smaller than 0 yet. But the point is, if I'm moving to the right of 0 on the number line, I'm getting positive values. When I move to the left, I'm losing or I'm getting negative values. And we'll talk more about what negative means. So I'm going to go backward because it says if this is plus, then that's minus. So if this is left, then that's right. And that's all that little symbol means. It means the opposite of. This negative, this subtraction, negative means the opposite of. What's the opposite of to the right? It's to the left. Okay? So since I went to the right for 5, the opposite of that will be to the left. So there's 1, 2, 3 places. 3 is how the farther it tells me to go. So I'm going to stop and I'm going to analyze what position am I on the number line. That's right, I'm on 2. Almost made my own mistake. And 5 is 2 more than 3, right? There you go. And finally, abstractly, I can skip count, jump 5, and count down now instead of counting up. So from 5, I'm going to go down 3. 5, 4, 3, 2. I went down 3, and where did I end? I ended at 2. Okay? It's just that simple. I've skipped counted, or I counted down instead of counting up. I didn't skip count because I went by ones. Okay? 2 is the final answer, and this is the final screen. And I want to thank you. I hope this was helpful. And please look at the next one. It is multiplication of whole numbers. And I look forward to seeing you there.